Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today we are discussing working memory. Working memory is a special category of memory in which we are able to hold small amounts of information in our mind for short periods of time. Working memory is also very closely related to attention. So for any of you that are interested in how to develop better focus and attention, understanding what working memory is and some of the things that you can do to improve your working memory can be very beneficial. Today I'm going to talk about what working memory is, including some of the underlying biology, although I promise, irrespective of whether or not you know any biology or you are an expert in biology, I'll make the conversation accessible to you. In addition, I will talk about tools to improve working memory, and I'll also compare working memory to other forms of memory like long-term memory and short-term memory. And through that understanding, I'm confident that you'll be able to develop better focus as well as be able to commit certain forms of information to your short and long-term memory stores. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. In keeping with that theme, I'd like to thank the sponsors of today's podcast. Our first sponsor is Mateina. Mateina makes loose-leaf and ready-to-drink yerba mate. I often discuss yerba mate's benefits, such as regulating blood sugar, its high antioxidant content, the ways that it can improve digestion, and possible neuroprotective effects. I also drink yerba mate because I love the taste. While there are a lot of different choices of yerba mate drinks out there, I love Mateina because, again, they have the no sugar variety, as well as the fact that both their loose leaf and their canned varieties are of the absolute best quality. So much so that I decided to become a partial owner in the company. Although I must say, even if they hadn't allowed me to do that, I would be drinking Mateina. It is the cleanest tasting and best yerba mate you can find. I love the taste of brewed loose leaf Mateina yerba mate, and I particularly love the taste of Mateina's new canned cold brew zero sugar yerba mate, which I personally helped them develop. If you'd like to try Mateina, go to drinkmateina.com/Huberman. Right now, Mateina is offering a free 1-pound bag of loose-leaf yerba mate tea and free shipping with the purchase of 2 cases of their cold brew yerba mate. Again, that's drinkmateina.com/Huberman to get the free bag of yerba mate loose-leaf tea and free shipping. Today's episode is also brought to us by BetterHelp. BetterHelp offers professional therapy with a licensed therapist carried out online. Now, I've been going to therapy for well over 30 years. Initially, I didn't have a choice. It was a condition of being allowed to stay in school. But pretty soon I realized that therapy is extremely valuable. In fact, I consider doing regular therapy just as important as getting regular exercise, including cardiovascular exercise and resistance training, which of course I also do every week. The reason I know therapy is so valuable is that if you can find a therapist with whom you can develop a really good rapport, you not only get terrific support for some of the challenges in your life, but you also can derive tremendous insights from that therapy. Insights that can allow you to better not just your emotional life and your relationship life, but of course also the relationship to yourself and to your professional life, to all sorts of career goals. In fact, I see therapy as one of the key components for meshing together all aspects of one's life and being able to really direct one's focus and attention toward what really matters. If you'd like to try BetterHelp, go to betterhelp.com/Huberman to get 10% off your first month. Again, that's betterhelp.com/Huberman. Today's episode is also brought to us by Helix Sleep. Helix Sleep makes mattresses and pillows that are of the absolute highest quality. I've spoken many times before on this and other podcasts about the fact that sleep is the foundation of mental health, physical health, and performance. One of the key things to getting a great night's sleep is to make sure that your mattress matches your sleep requirements. The Helix website has a brief 2-minute quiz that if you go to, it will ask you questions such as, do you sleep on your back, your side, or your stomach? Do you tend to run hot or cold during the middle of the night? As well as some other questions that allow you to determine the optimal mattress for you. When I took the quiz, I personally matched to their Dusk mattress, D-U-S-K, which has allowed me to significantly improve my sleep. So if you're interested in significantly improving your sleep, go to helixsleep.com/Huberman. Take their brief 2-minute quiz and they'll match you to a customized mattress. And you'll get up to $350 off any mattress order and 2 free pillows. So again, if you're interested in trying Helix, go to helixsleep.com/Huberman for up to $350 off and 2 free pillows. Okay, let's talk about working memory. And let's start off this discussion by comparing working memory to other forms of memory that most people are more familiar with, or at least when most people hear the word memory, they typically are thinking about long-term memory, like one's ability to remember the capitals of states or countries, the different continents, directions from one location to another, even one's name. All of those things are examples of long-term memory. Now, I want to emphasize that long-term memory really has 2 components. There are what we call declarative long-term memories. So these are the things that we can declare, things like facts about ourselves or the world or others. And then there are procedural long-term memories. Procedural long-term memories, as the name suggests, are aspects of our memory that allow us to perform certain procedures. They are literally action steps that we take to, for instance, ride a bicycle or drive a car, which, by the way, we might not be conscious of ourselves doing after we learn. That is, after we pass information into our procedural long-term memory. But even once those things become reflexive, they are stored in our long-term memory. Now, a discussion of long-term memory is not the focus today, but me being a neuroscientist, and I like to think you all generally being interested in the underlying biology, I'll just mention that there's a key structure within the brain that is part of a larger neural network that is a collection of structures which is absolutely essential for the formation and storage of long-term memories. And that's the hippocampus, which in Latin means seahorse. And it does look a little bit like a seahorse, but we actually have one on each side of your brain, so we say hippocampi, plural. And so what we know is that if people have damage to their hippocampus of any kind, that people have trouble accessing or forming long-term memory, sometimes both. And there's a lot more that we could say about long-term memory. Indeed, I did an entire episode of the Huberman Lab podcast about the formation and storage of long-term memories, including some tools to improve long-term memory. We'll touch on a few of those tools later today, but you can access that episode if you go to hubermanlab.com and just put memory into the search function and you'll find it there. In the meantime, if we want to understand working memory, we not only have to understand how it's different from long-term memory, but also how it's different from short-term memories. Short-term memory is a capacity that we all have that, as the name suggests, represents a short-term memory bank for information that may or may not get passed into long-term memory. So for instance, if you've learned anything, and of course you have, if you can understand what I'm saying, you've learned English language. If you can write, you've learned how to write, etc. Well, in order to learn those things and to commit them to long-term memory, the information required to do those things and to have that knowledge needed to be held in short-term memory. And short-term memories are the sorts of memories that we maintain for somewhere between a few minutes and potentially a few hours, maybe a little bit longer. But only a certain percentage of that is passed into our long-term memory. So for instance, if you listen to this podcast or you go to a course lecture, whether or not that lecture is about cognitive material or whether or not it's about learning a new physical skill, regardless of what you learn, you're only going to learn a certain amount of that information. But were we to examine how much of the information you just heard or that you're hearing now you remember immediately after this podcast episode, as compared to, say, a week later, we know, based on, probably millions of scientific papers and studies, that you are going to have more information in your short-term memory stores shortly after being exposed to new information than you will later. In other words, only a small percentage of what we perceive, what we see, what we hear, etc., gets passed into short-term memory, and then only a fraction of that gets passed into long-term memory. Now, the neural circuits for short-term memory and the passage of short-term memories into long-term memory involve a lot of different brain structures, but here again, we can implicate the hippocampus because the actual passage of short-term memories into long-term memories occurs in part within the hippocampus. And then a lot of people don't know this. Some of the memories that we think of as long-term memories are actually distributed into the neocortex, which is the outer portion of the brain. Now, the point here is less to fill your mind with different names of things and nomenclature, but rather to get you thinking about what's involved in creating short and long-term memories. And equally important, that even though the hippocampus is critically involved in the formation of short and long-term memories, that The formation of short and long-term memories is really a network phenomenon. In fact, among the more important themes that comes up again and again on this podcast, anytime that we're talking about neuroscience, or actually biology in any case, is that rarely, if ever, is there one location in the brain where something happens. Typically, it's a network phenomenon, meaning it's the collaboration of a bunch of different brain areas passing information from one location to the next and storing it in a kind of distributed way. Now, another key thing to understand about working memory and how it is different from short and long-term memory is that the formation of short and long-term memories almost always involves neuroplasticity. Neuroplasticity is the nervous system's ability to change in response to experience. Now, there are different types of neuroplasticity. So often when we hear about neuroplasticity in the popular sphere, people don't emphasize that there are different types of neuroplasticity, and it's worth paying a little bit of attention to what those different types are. There is, for instance, what we call long-term potentiation. Long-term potentiation, or LTP, as the acronym goes, is the strengthening of connections between neurons as a consequence of their repeated firing very closely together in time. Okay, there's a lot more to it, but if you've ever heard the phrase fire together, wire together, sometimes that is misattributed to Donald Hebb, who did talk about neuroplasticity. By the way, Donald Hebb was a psychologist up in Canada who talked about neuroplasticity in the context of lots of different forms of learning. But that fire together, wire together phrase was not actually stated by Donald Hebb. It was stated by Carla Schatz, my colleague at Stanford. And she was referring to LTP, but other forms of neuroplasticity that occur mainly in development when neurons fire very closely in time and thereby strengthen those connections, which can include LTP, okay? So for now, think of LTP as any time that some small group of neurons, could be 2 neurons, could be 2,000 neurons, are very active closely together in time, and they have access to one another physically. And the consequence is often, not always, but is often LTP. That is the strengthening of those connections such that after that barrage of activity subsides, those neurons can speak to each other. They can communicate through electrical activity and chemical activity much more easily. Their communication is more robust. It's like removing a wall between a conversation such that the conversation can take place more fluidly. Now, there are other forms of neuroplasticity, including LTD, long-term depression, which unfortunately, the name often calls to mind ideas about depression as a psychiatric or a psychological symptom, but it has nothing to do with that. Long-term depression is simply the inverse of LTP. It's actually the weakening or the removal of connections that we call synapses between neurons. I want to emphasize that both LTP and LTD are both critically involved in lots of different kinds of learning, and both of them tend to be involved in the formation of both short-term memories and long-term memories. And this is very important, in the removal of short-term memories and long-term memories, literally forgetting of certain things, because as we all know, there are many things that we will never forget, and there are also things that we almost always forget. Now, there's a third form of neuroplasticity that's involved in the formation of short and long-term memories that's important for us to discuss just briefly. But I do want to emphasize that there are not just 3 forms of neuroplasticity. There are many other forms, dozens, if not more, things like spike timing dependent plasticity, paired pulse facilitation, and on and on. But the third type of neuroplasticity that I'd like to mention now is neurogenesis. Neurogenesis is the formation of new neurons. Now, neurogenesis is robust in the developing nervous system. We know this. It's robust in the developing nervous system of animals and humans. However, neurogenesis, the literal formation of new neurons in the brain, is a very exciting idea, and it does occur. And it's very exciting in a way that has motivated lots of popular press outlets to talk about or to discuss papers that have discovered neurogenesis in the adult brain. Because let's be honest, what's more exciting than the idea that your brain can add new brain cells later in life? And indeed, that has been shown even in people well into their 80s and 90s. However, it's very important to know that the total amount of neurogenesis that occurs in the adult human brain is infinitesimally small as a mechanism for neuroplasticity and learning as compared to the other forms of neuroplasticity that we discuss, such as long-term potentiation and long-term depression. So I don't want to, throw cold water on the topic of neurogenesis. It's an incredibly interesting and important topic, but all too often they tend to eclipse the much more common mechanism for the formation of short and long-term memories, which are those other forms we just talked about, LTP, LTD, etc. So The point here is that, yes, indeed, there are new neurons that can be added in the adult brain, maybe even in the adult human brain. And there is some evidence that some of those new neurons are added to the hippocampus. In fact, a particular region of the hippocampus called the dentate gyrus of the hippocampus. And there's been a lot of controversy about how much neurogenesis occurs or doesn't occur, and whether or not it occurs after puberty or not. There's a whole field of people battling over this now for several decades. But one thing is very clear. Neurogenesis, while it's very exciting and intriguing, is not the main mechanism by which the formation of short and long-term memories occurs. When you learn new information, as you are right now, the storage of that information in your short-term memory networks, which is then passed on to your long-term memory networks and that can be recalled, that allows you to state certain facts about, for instance, the existence of this thing called a hippocampus. Hopefully you will remember that going forward. Or your ability to perform any kind of motor movement that you learned now or way back in childhood. Most of that is the consequence of the strengthening of particular connections and the weakening of other types of connections. Those are the two major forms of neuroplasticity. Okay, so I don't want you to get the impression that there's something wrong with my memory and that I forgot that this episode is not about short or long-term memory, but it's about working memory. And indeed, I have not forgotten. So now is where I tell you why I've been talking about short and long-term memory and the mechanisms of those. Because I want them to provide a stark contrast for what we call working memory. Working memory, as far as we know, does not involve neuroplasticity, or at least if it does, it's not a particularly robust aspect of working memory. Rather, working memory is the reflection of a particular neural circuit running an algorithm over and over and over for different types of information, but the information isn't stored, it is actually intentionally discarded. Now, what sorts of daily activities and life activities would require working memory? The answer to that is basically everything that you need to do, but that you don't want to remember. Now, what types of things would those be? Well, let's think about it. Most all of us learned at some point in our life to tie our own shoes. Presumably, you know how to tie your own shoes. If you don't, perhaps you should learn, or wear Velcro or slippers. I don't know, but assuming you can tie your own shoes, that's something that you know how to do, and you can do it as a procedural long-term memory. You can do that action. You don't have to think about it too much. Working memory would come into play when, say, you wake up in the morning and you know that you need to head out for a jog, but you also need to make a cup of coffee first, and you need to remember where the coffee is, where your shoes are, and perhaps you're making a phone call or you're having a conversation while you need to tie your shoes, and so on and so forth. Working memory is basically the taking in of information that's critical for you to sequence your actions over a short period of time and then forget that sequence. For instance, I'm willing to bet that you put your shoes on to go running before you go running. That's sort of a duh. And if you're like me, you drink your water, your coffee, your yerba mate before you go running. The point here is that if you wake up in the morning and you like caffeine before you go for a run, there are a certain series of action steps that you need to carry out to hydrate, make that cup of coffee or tea, drink it, put on your shoes, head out the door. You need to sequence things properly, but you don't want to commit your long-term or even your short-term memory stores to carrying out that sequence. You simply want to be able to carry out that sequence and then discard that information about the sequence and focus your attention on, for instance, what trajectory you're going to run through the park or around your neighborhood. Then you want to discard that information and you want to lean into the next portion of your day, and so on and so on. In fact, working memory is involved in essentially every activity, both cognitive and motor, from the point you wake up in the morning until the time you go to sleep at night, for every single day of your life. And we know this because there are indeed people who have diminished working memory or even lack working memory entirely, although the latter is somewhat rare. It has happened. And as you can imagine, they have a complete failure of ability to sequence activities, and their lives are extremely difficult. They need a ton of assistance from other people, even more assistance than do people who have minimal or no long-term memory. Okay, so this is really highlighting just how important working memory is. Working memory is basically the way that you navigate any immediate environment. And as I mentioned earlier, it's very closely tied to attention, because in order to know what to do now and then what to do subsequently and then subsequent to that, you need to be able to hold your attention to the things you need to do. So working memory and attention collaborate literally at a neural circuit level and at a neurochemical level in order to allow you to move through your day in an adaptive, functional way. And people who have challenges with attention or focus or working memory, and sometimes it can be hard to dissociate which one they're having challenges with, really have a hard time moving through life as compared to people whose attention and working memory is more robust. Now, the good news is today we're going to talk about working memory, some of the neural circuits involved, and some of the neurochemicals involved that can augment or improve working memory. And we're also going to talk about what one can do to directly increase the amount of neurotransmission of those particular chemicals within the circuits that control working memory. In other words, to improve your working memory. Now, I can talk about working memory and the mechanisms, etc., all day long. But as is often the case, sometimes it's better to not just learn about concepts, but actually to experience them in real time. So what we're going to do now is I'm actually going to give you a working memory test. This is the sort of working memory test that you would take if you were to go into a psychology laboratory or a neuroscience laboratory and they were studying working memory in humans. Now, there's another advantage to us doing this in real time, right here as you're listening, or as you're listening and watching. And that's because you're going to get data. You're going to get information about what your baseline working memory capacity is. And you're going to want to keep those data in your short-term memory stores, maybe even your long-term memory stores, but certainly your short-term memory stores, because shortly later in this episode, I'm going to talk about different ways to improve your working memory depending on where your baseline working memory starts, which, by the way, turns out to be a pretty good proxy for the levels of a neuromodulator called dopamine within the neural circuits that control working memory. So right now, let's take a working memory task. We're going to do this purely through audio form because I realize some people are watching and listening to this on YouTube and others are just listening to this episode. So there are not going to be any visual cues or slides that I present. And that's perhaps what distinguishes what we're about to do most from what would happen in a laboratory. Typically in a laboratory, there would be some visual presentation of what I'm about to say. But here, because of the format that most of you are consuming this information by, we're going to do this purely by audio. So the first test of your working memory is very simple. I'm going to read off a series of letters, and your task is to remember as many of those letters as you can. The first string of letters is J, K, Z, P, I. Okay, just to make this really easy, I'm going to say it twice. Although typically in a working memory task, it would just be said once, but I'm going to make this extra easy. J, K, Z, P, I. Okay? Now, you in your own head can try and recite back those letters if you like. Okay, second string of letters. R, O, M, K, L, E. I'm going to make this extra simple and do it again. Not typical for a working memory task, but there are some working memory tasks where that happens. R, O, M, K, L, E. Okay. Now a third string of letters. This one's going to be a little bit longer. So cue up that working memory and attention. W, A, C, Q, V, D, N. I'll repeat that again. W, A, C, Q, V, D, N. How many of the letters I just read can you remember? Okay, so depending on how many letters you can remember, perhaps you have a low, moderate, or high degree of working memory. Keep in mind that some of you are perhaps doing other things, you're attending to driving or other tasks within your home or your office, and so perhaps you weren't able to pay full attention, so there'll be some variation there. But nonetheless, after reading each of those strings of letters, you were asked to recall those letters in your mind. And if you wrote them down and you're rereading them, yes, that's cheating. But how about this? What if I were to ask you now about the simplest first string of letters, the one that consisted of only 5 letters? How many of you can remember any of those 5 letters now? Okay, I can't hear you if you're shouting them out. I can't see you if you're raising your hand. But chances are most of you have forgotten the first series of letters, even though it was quite short and you could remember it early on. That ability to remember that string of letters when you first heard them, and indeed I read them twice, so I'd be very surprised if any of you couldn't remember that string of letters after hearing them twice. But I also read you some other letters in the interim, okay? So that now, just a couple minutes later, I'm asking you to remember that first string of 5 letters. And assuming that you didn't write it down and you're not cheating, chances are you remember anywhere from 2 to 0 of those letters in that first word, which is a perfect example of your working memory. Nothing got committed to short-term, much less long-term memory. Rather, your working memory was able to work with that information, hold it in mind for just as long as you thought you needed to know that information, but then, thank goodness, that information was discarded. You didn't know that I was going to ask you for that first string of letters again after reading you the longer string of letters, but I did that deliberately to show you how your working memory works. So in some sense, the working memory task is a bit unusual in that it's a test of, yes, memory in the very, very short term, but also a test of your ability to forget, to discard information that's not critical. And that gets us back to the original definition of working memory, which is our ability to attend to specific small batches of information, remember it for just as long as we think we need to, and then to discard that information. And by the way, if you want to know what those first 5 letters were, they were J, K, Z, P, I. I'd like to take a brief moment and thank one of our sponsors, and that's AG1. AG1 is a vitamin mineral probiotic drink that also contains adaptogens. I started taking AG1 way back in 2012. The reason I started taking it and the reason I still take it every day is that it ensures that I meet all of my quotas for vitamins and minerals. And it ensures that I get enough prebiotic and probiotic to support gut health. Now, gut health is something that over the last 10 years, we realized is not just important for the health of our gut, but also for our immune system and for the production of neurotransmitters and neuromodulators, things like dopamine and serotonin. In other words, gut health is critical for proper brain functioning. Now, of course, I strive to consume healthy whole foods for the majority of my nutritional intake every single day, but there are a number of things in AG1, including specific micronutrients that are hard to get from whole foods, or at least in sufficient quantities. So AG1 allows me to get the vitamins and minerals that I need, probiotics, prebiotics, the adaptogens, and critical micronutrients. So anytime somebody asks me if they were to take just one supplement, what that supplement should be, I tell them AG1, because AG1 supports so many different systems within the body that are involved in mental health, physical health, and performance. To try AG1, go to drinkag1.com/Huberman, and you'll get a year's supply of vitamin D3 K2 and 5 free travel packs of AG1. Again, that's drinkag1.com/Huberman. So now's where we talk a little bit about the neural circuitry and the neurochemistry of working memory. Now, it's important that we do this because in a few minutes, you're also going to learn that people generally fall into 2 broad bins of having a high or low baseline of a certain neurochemical in the brain that affords them either high or low working memory capacity. Now, in reality, it's a distribution. In fact, it's what we call a normal distribution, so it really isn't 2 bins. But during today's discussion, and in fact in a lot of laboratory studies, we can actually bin people into these 2 groups. The neural circuitry underlying working memory involves a lot of different brain locations, that is, a lot of different neural networks collaborating to create this thing we call working memory. However, there are a couple of key hubs, that is, locations within the brain, that are especially important for working memory. The ones that I'd like to focus on today involve the prefrontal cortex. So this is neural real estate that resides just behind the forehead, and the neurons in the brainstem, so further back in the brain, that manufacture dopamine and that send their little wires that we call axons up to the prefrontal cortex to release dopamine. Dopamine is a neuromodulator. Many people are familiar with dopamine and familiar with it in the context of motivation and drive. Sometimes people mistakenly think it's only involved in pleasure, but dopamine is involved in motivation and drive. When dopamine systems go awry, that is, if their levels get too high, that can create manic states, it can create addictive states. When dopamine levels are too low, you can get movement challenges, such as in Parkinson's, which is a deficit or a literal destruction of the neurons that manufacture dopamine. There are a bunch of different areas of the brain that those dopamine neurons in the brainstem project to, but for right now, we're going to focus almost entirely on the dopamine projections from the brainstem to the prefrontal cortex, which is called the mesocortical circuitry. I'm not going to get into the origins or the meaning of the mesocortical versus other dopamine projection systems. I did that in a couple of episodes about ADHD and attention and dopamine in particular, and you can find those at hubermanlab.com. Just put dopamine and circuits into the search function, and it will take you to those particular timestamps where I describe that. But Since we want to keep things fairly top contour at the level of neural circuitry here, just know that there are a bunch of neurons that manufacture dopamine back in the brainstem that send their axons, those little wires, up to the prefrontal cortex, and that the amount of dopamine released per unit time, so in a certain amount of time, strongly dictates the extent to which working memory capacity is going to be high, medium, or low. Now, I want to be very clear because I'm going to come back to this a little bit later again and again. It is the case that when dopamine levels are lower, that is, either there are fewer neurons that have the potential to release dopamine in the frontal cortex, or for whatever reason, less is being released in the frontal cortex, that working memory performance tends to be lower as compared to conditions where dopamine release or the availability of dopamine is higher. However, it is not the case that more dopamine is always going to equate to improved working memory. This is so important that I'm going to say it again. It is not always the case that increasing the amount of dopamine transmission in the frontal cortex leads to improvements in working memory. There is a specific criteria that allows us to predict whether or not it will improve or maintain or actually degrade working memory performance. So before you head to the end of the podcast to try and figure out ways to increase dopamine to improve working memory, please keep that fact in mind. Don't just commit it to your working memory, commit it to your short and long-term memory, because that's very important if your goal is to improve your working memory. With that said, I do want to describe just a little bit of research showing the relationship between having a low working memory span, as it's called, the ability to only remember a few letters or numbers or short batches of information, as compared to a high working memory span, meaning longer strings of letters, longer strings of numbers, which of course in the real world translates to being able to carry out shorter versus longer action sequences, as described earlier in the scenario where you're getting up in the morning and you're making coffee and you're heading out for a run, et cetera, et cetera. People do differ in terms of their working memory capacity. And there's a classic study done by Cools and Desposito and colleagues, this was published in 2008, where they had a way to label the amount of dopamine that is available for release in the frontal cortex in human subjects. They did this by the injection of a specific dye. That dye gets taken up specifically by the neurons in the brain that manufacture dopamine. Then they were able to image the brains of those people while those people were wide awake using something called positron emission tomography. Again, the specific tool isn't necessarily important, but since some of you like to know. And what they found is that for people that had a high working memory span, that is, could remember long strings of numbers or letters or other information, they tended to be the people that had more dopamine available for release in the frontal cortex, either because they had more of the dopamine neurons themselves or similar number of neurons, but those neurons had more dopamine to release, okay? And they also found the converse. Individuals that had a low working memory span and ability had less dopamine available for release. So that establishes a correlation, but it's not causal. A different study, which is also a classic, was carried out by Brzozowski, Brown, Rosvold, and Goldman. And this is a really important study because in this study, they were able to introduce small amounts of dopamine directly into the cortex and evaluate working memory capacity. Now, anytime a working memory test is done, the same pattern always emerges. This is regardless of any dopamine being infused into the brain, which is people and animals for that matter are very good at remembering short spans of numbers, letters, or other types of information. So if you tell them one thing, like the letter A, and then you ask them, do you remember the letter? Almost everybody remembers that. But if you give them a string of 10 letters, they remember fewer of those 10 letters. That's sort of obvious, but it's an important point to emphasize nonetheless. And so there's a kind of a dropping off curve of performance as one progresses from fewer to greater number of items to be remembered. In this study, when dopamine was introduced to the frontal cortex, the number of things that individuals could remember simply increased. It was a very straightforward result. More dopamine introduced allowed longer letter, number, and information strings to be remembered. And of course, forgotten, because that's what working memory involves. Remembering and then discarding of information shortly thereafter. Now, the findings that I just described complement what I said before, which is the naturally occurring experiment. Bring people into the lab, measure their working memory span, look at how much dopamine they make. Higher dopamine, better working memory. Lower dopamine, lower working memory. The experiment I just described was one in which dopamine is introduced, showing that dopamine is very likely the rate limiting or the capacity limiting, it's probably the better way to put it, the capacity limiting neuromodulator for improving working memory. That's a fancy nerd speak way of saying more dopamine allows for better working memory. But a critical feature of this experiment is that they did a number of experiments where they didn't introduce dopamine, but instead they introduced other neuromodulators to the prefrontal cortex, such as norepinephrine or serotonin. And the interesting finding is that the addition of norepinephrine or serotonin, which of course are other neuromodulators that can change the firing patterns of neurons in the prefrontal cortex, but elsewhere as well, it's just that in this case they were added to the prefrontal cortex, had no effect on working memory. It neither improved nor degraded working memory when those neuromodulators were introduced. In other words, dopamine, and perhaps only dopamine, seems to be the dominant neuromodulator for regulating the degree, that is, whether or not you have small, medium, or large amounts of working memory capacity in the prefrontal cortex. And of course, there have been a bunch of other experiments that are worth mentioning briefly in this context, such as taking people that have a high working memory capacity and indeed have their brains imaged, and one sees that they have high levels of baseline dopamine, especially the dopamine projecting to the prefrontal cortex, and then they're given a drug that depletes dopamine within the prefrontal cortex, and their performance drops. And so what's so nice about the literature around working memory is that while I'm not covering all of that literature exhaustively, it all tends to jive. It all points in a direction whereby the levels of dopamine being released in the prefrontal cortex during working memory tasks correlates very strongly with capacity to perform working memory tasks. Lower dopamine, lower working memory span, as it's called. Higher dopamine, higher working memory span. Okay, so next we're going to do another working memory task, different than the one we did earlier. And we're going to do that with a specific purpose in mind, which is for you to be able to determine what your working memory capacity is, and by extension, your baseline levels of dopamine, or at least the levels of dopamine that are likely being released into your prefrontal cortex while you do these working memory tasks. In other words, we're going to try and figure out whether or not you are of the low, medium, or high working memory capacity. And of course, we're doing that in part to try and establish whether or not you likely have low, medium, or high amounts of dopamine available for release in the prefrontal cortex. Now, of course, we're not putting you into a positron emission tomography scanning device. We aren't able to do that for obvious reasons. But keep in mind that what we are about to do is very similar and in some cases identical to laboratory studies where the researchers were trying to determine what people's levels of dopamine within these particular neural networks we've been discussing, the mesocortical pathway, are likely to be. In other words, performance on the working memory task that we are about to do is a decent indication of what the dopamine levels that are available for release in your prefrontal cortex perhaps might be. Now, I say perhaps might be because I don't want to cause any unnecessary alarm if, for instance, you fall into the low working memory span group. In fact, if you fall into the low working memory span group, there are actually some terrific tools that you can use to improve dopamine transmission in those pathways and improve your working memory. I also don't want people to get the impression that somehow performance on this working memory task is reflective of some larger dopamine issue in the brain. And certainly it is not, I repeat, it is not diagnostic of Parkinson's or any kind of neurodegenerative condition. Although I will say that deficits in working memory are common in patients with Parkinson's for obvious reasons. Those patients have deficits in dopamine neurons, not only production, but the number of dopamine neurons. It's one of the hallmark features of Parkinson's, but also in things like traumatic brain injury, et cetera. But the working memory task that you're about to take, when given to a general population or a group of undergraduates or so-called normals or typical control subjects, which all of you are, okay? So unless you're dealing with a traumatic brain injury or you have Parkinson's, we know that the data that you're going to get back right now is very similar to the data that people get back when they do these sorts of studies in a laboratory. That is, it's typical for some people to have a short working memory span, some people to have a medium working memory span, and some people to have a high working memory span. And today we're actually just going to divide into two bins, short working memory span and high working memory span. And we can have some degree of confidence that correlates with the amount of dopamine available for release in the frontal cortex. But, and this is a very important point, as we progress along this discussion of working memory, the neural circuits, dopamine, et cetera, I want to make clear something that I said earlier, which is that it is not the case that increasing the amount of dopamine that's available always increases working memory span. In fact, there's a common circumstance whereby people with a relatively high degree of working memory capacity increase their dopamine levels even further using pharmacology or other methods that we'll discuss, and their performance actually can degrade, okay? So if any of that is confusing now, we'll make it all very simple going forward so that if you decide to implement any of the protocols discussed in this episode, that you are aware of what you can expect and whether or not you are in the category of people that should or perhaps should not incorporate those protocols. Okay, let's test your working memory again. This time, the working memory task is going to be a little bit different than the one you did previously. This working memory task involves me reading 6 different sentences to you. And your job is to pay attention to these 6 sentences because you're going to be asked some information about these sentences in a few moments. The first sentence is, real estate costs are going up. The second sentence is, the Atlantic Ocean is warm in summer. The third sentence is, there's a lot of interest now in electric cars. The fourth sentence is, some reptiles eat only once a year. The fifth sentence is, kids nowadays look at screens more than 60% of their waking life. And the sixth and final sentence is, football can mean different sports depending on the country. Okay, so I read you 6 sentences. They were moderately long, I confess. Your job for the working memory task is now to recall as many of the final words of each of those sentences as you can. I'll give you a few moments to do that. Now, before I tell you what the final word of each of those sentences actually is, I want to remind everybody that working memory capacity follows a normal distribution. So some of you will be able to remember the final word of perhaps 5 or even 6 of those sentences, although I must say that is exceedingly rare. Some of you are going to be able to remember 3 to 4 of the final words of those sentences, and that's more typical. That actually represents the average, or the mean, as we call it. And then fewer people, although still many of you, will only be able to remember 1 or 2 of the final words of those sentences. Okay, so now I'm assuming that most of you have tried to call to memory the final word of as many of those 6 sentences as you can. And maybe you've written them down, or you've typed them into your phone, or you have some record of what you recall those 6 final words of those sentences are. Now I'm going to tell you the actual final word of each of those sentences. The final word of the first sentence was up, because as you may recall, the sentence was, real estate costs are going up. The final word of the second sentence was summer, because the sentence was, the Atlantic Ocean is warm in summer. The final word of the third sentence was cars, because the sentence was, there is a lot of interest in electric cars. The final word of the fourth sentence was year, because the sentence was, some reptiles eat only once a year. The final word of the fifth sentence was life, because the sentence was, kids nowadays look at screens more than 60% of their waking life. And the final word of the sixth sentence was country, because the sentence was, football can mean different sports depending on the country. Okay, so be honest with yourself and tell yourself, and you don't have to tell anyone else if you don't want to, how many of the final words of those 6 sentences you could remember correctly. It's important that you remember them correctly. Again, the number of words that you can recall, that is your working memory span, is going to vary from person to person. But we can take the normal distribution of those scores and sort of draw a line down the middle and say that if you could remember 3 to 6 of the final words of those sentences correctly, you're going to fall into the high working memory span group. Whereas if you could only remember 1 or 2 or maybe 0 of the final words of those 6 sentences, then you're going to be in the low working memory span group. Again, I don't want to alarm anybody. This doesn't mean that you have any global memory deficits or dopamine deficits, but it is important, especially if you plan to apply any of the protocols to improve working memory, that you faithfully, that is, you accurately report your working memory performance, at least to yourself. Now, as you recall, whether or not you have low or high, and here we are just binning into low and high, there's no medium. We've divided right at that line. We're saying if you can remember 3 to 6, we're calling that high working memory span, at least for this discussion. And if you can remember fewer than 3, even down to 0 of the final words of those sentences, that's low working memory span. We're dividing it in 2. We divided you into 2 groups. And we do know when this has been done in large numbers of human subjects, and some, in some cases all, of those subjects have their brains imaged for the amount of dopamine available for release in their prefrontal cortex. That short working memory span correlates with lower amounts of dopamine, whereas higher working memory span or longer working memory span, whatever you want to call it, correlates with more dopamine available for release in the prefrontal cortex. Now, this is where things get really interesting and frankly, really exciting for everybody, especially the folks in the low working memory span group. Work from Marta Esposito and colleagues at UC Berkeley, as well as other laboratories, have explored the consequences of increasing dopamine levels in the brain of typical populations of individuals. So these are not people with Parkinson's or TBI, but undergraduate students, which we do realize is not completely representative of the quote unquote normal population outside the university, but also people from the community. So people who are not university students and so on. And the ways that they've increased dopamine in those individuals have tended to rely on pharmacology. So these are prescription drugs that most often have been developed for the treatment of Parkinson's in order to increase dopamine levels, but for some other purposes as well. Drugs like bromocriptine, which we know are so-called dopamine agonists. An agonist is a drug that has the consequence of increasing the amount of a given neurochemical, in this case, dopamine, whereas an antagonist is a drug that either blocks or prevents or somehow lowers the total available amount of a certain chemical, such as dopamine or serotonin, et cetera. So bromocriptine is a drug that increases dopamine. So when human subjects came into a laboratory, didn't take any drug, no bromocriptine yet, and of course, they were being evaluated for whether or not they were taking any meds for ADHD, their caffeine consumption, et cetera. There were certain rule-ins and rule-outs for that study. But certainly people that were taking any kind of prescription medication for ADHD were not included in the study or were eliminated from the study because those drugs can indeed increase dopamine as well as some other neuromodulators such as norepinephrine and epinephrine. I covered all that in the 2 ADHD episodes that I did, which again, you can find at hubermanlab.com. Just go to the search function, put in ADHD. In any event, in these studies, they took people that had not taken any drugs to increase dopamine, had their working memory measured, very similarly to the way that you measured your working memory a few minutes ago with the 6-sentence business that we did. And then they took bromocriptine. And they either took a low, a moderate, or high dose of bromocriptine. And 90 minutes later, they took a working memory task. And what was observed was very interesting. You can probably predict what it is based on everything I've said up until now. Individuals that initially had low baseline levels of dopamine and therefore shorter working memory span, so they only remembered 0 to about 3 of the final words of that 6-sentence series, their performance significantly improved. They were able to remember 4 and in some cases up to 6 of the final words of those sentences. Now, that is in complete agreement with everything we said up until now. It simply says that dopamine is important for working memory. If you start off with lower dopamine stores or dopamine availability for release in the prefrontal cortex, lower working memory performance, increased dopamine through ingestion of bromocriptine, which is this dopamine agonist. All of the circuit changes that we want and would expect to improve working memory occur, and indeed working memory improves. Okay, very straightforward. That's interesting, but the even more interesting part of the study is that individuals that already had high working memory span, when they took bromocriptine at a low or a moderate dose, their working memory did not increase further. Now, if somebody was already getting 6 of the final words of those 6 sentences, well, then of course they couldn't improve their performance anymore. But many of the people in the high working memory span group, of course, only remembered 4, in some cases 3. Typically it would be 4, 5, or 6 of the final words of those sentences. When they took bromocriptine at low or moderate doses, their working memory did not improve significantly. There was either no change or a very modest change. And here's where things get really interesting. When individuals who already had a high working memory span took the highest dose of bromocriptine, and by the way, studies verified that the amount of dopamine available indeed increased, so that was important to do, and they did that. Well, their working memory performance actually decreased, such that now they had a short or a low working memory span. So what this tells us is that the relationship between dopamine and working memory follows an inverted U-shaped function. So imagine a U and then just flip it over, meaning if you have low dopamine availability in the prefrontal cortex, working memory span is short. As you increase that amount, working memory becomes greater, but if you increase the amount of dopamine in the prefrontal cortex too much, working memory span actually drops significantly below the baseline that you started with. Now, this is important for a number of reasons, not the least of which is the known relationship between working memory and attention. Now, this is very important to understand in the context of ADHD, but also for people who don't have ADHD and are struggling to maintain focus and attention and carry out working memory tasks throughout their normal everyday life, not in the laboratory, but just moving through life. Because these days we hear a lot about people struggling with focus and attention. Perhaps, we don't know, perhaps in part due to overuse of smartphones, social media, et cetera, although there's not yet a direct causal relationship that's been established. The data that are emerging suggests that indeed overuse of those things can cause problems, but regardless of the source, there does seem to be more ADHD both in kids and in adults and subclinical challenges in focus and attention. And here's where things get really interesting as it relates to the neural circuitry. Work from Desposito and colleagues and other laboratories as well have shown, using the similar paradigm that I described before, of giving people drugs to increase their baseline levels of dopamine above their initial starting point of short or long-term memory span capacity, and then had people perform different types of working memory tasks that tap into two different aspects of attention and working memory. Up until now, we've been talking about working memory. It's kind of just one thing. But working memory actually involves two things, or at least two things. The first is that in order to carry out a working memory task and to attend to something, to really focus, we need the ability to rule out distractors. We need to be able to not pay attention to things that would otherwise distract us. In addition to that, we need to be able to switch from one context to the next, right? Making the cup of coffee to putting on one's shoes and heading out the door. And in some cases, layering different contexts together, talking on the phone while tying one's shoes, and so on and so forth. What this work shows us is that the ability to task switch and context switch, that is to shift around what it is that we're paying attention to and interleave different things that we're paying attention to, something that's so critical for moving through our daily lives, is largely dependent on the dopamine projections to a structure in the brain called the basal ganglia, which is a structure I've talked about before on this podcast, but if you didn't hear about it, we can just broadly define this structure as being involved in movement generation and stopping movement generation. In fact, it's often discussed as the neural circuitry that generates go, as in do commands, and no-go, don't do commands. So the basal ganglia are involved in task switching, and they are involved in task switching in part by sending certain commands to go, do certain things, and no-go to not do other things. Okay, task switching. Stop doing this, start doing that. Start doing that, stop doing this. And sometimes to varying extents, right? I mean, we could take any real world scenario of tying one's shoes while talking on the phone, and we could microanalyze it in the context of this. But I think if you think about it just a little bit, you understand that in order to perform daily tasks, we need to be able to task switch. And that's not always a start one task, end. Start a new task, end. Oftentimes we're interleaving different tasks to varying degrees. Now, the other aspect of working memory and attention is to eliminate distractions, to not pay attention to the irrelevant stuff in one's environment, or even the irrelevant stuff on your own body. Like you can't get distracted by, a button that, might be only partially buttoned, or maybe some little something on your sleeve if you're trying to do something else at that moment. Okay, and people with ADHD and people who have subclinical challenges and focus really have a hard time with this, right? The sort of stereotype is, oh, look, a squirrel, that whole thing. But really this typically exists as a more subtle and challenging phenomenon for people where they either can't remember what they were doing, or they're simply drawn down different trajectories, different thought trajectories or action trajectories, and then they have a hard time making it back to the original thing that they were trying to focus on. And we know, based on these studies of dopamine and neuroimaging, that eliminating distractors is largely the consequence of dopamine neurons projecting to the prefrontal cortex. Okay, now why am I telling you all this neural circuitry stuff? Well, yes, there are a bunch of studies showing that if you selectively activate the neurons that send dopamine into the basal ganglia, you improve task switching ability without an improved ability to rule out distractors. Or if you selectively increase the amount of dopamine from neurons projecting the prefrontal cortex, that you're able to selectively improve the elimination of distractors without improving task switching ability. For practical purposes in this discussion, we want to pay careful attention to whether or not the data tell us that those particular protocols, those particular approaches are globally increasing dopamine, that is increasing the activity of dopamine neurons projecting to the basal ganglia and the prefrontal cortex, or selectively to the basal ganglia or selectively to the prefrontal cortex. And what I can tell you now is that fortunately there are several protocols, some of which are behavioral, some of which involve specific over-the-counter supplements, and some of which involve prescription pharmacology, that can tap into each of these systems independently, as well as globally increase dopamine to improve focus and working memory at large. I'd like to take a quick break to acknowledge our sponsor, LMNT. LMNT is an electrolyte drink that has everything you need and nothing you don't. That means zero sugar and the appropriate ratios of the electrolytes, sodium, magnesium, and potassium. And that correct ratio of electrolytes is extremely important because every cell in your body, but especially your nerve cells, your neurons, relies on electrolytes in order to function properly. So when you're well hydrated and you have the appropriate amount of electrolytes in your system, your mental functioning and your physical functioning is improved. I drink 1 packet of LMNT dissolved in about 16 to 32 ounces of water when I wake up in the morning, as well as while I exercise. And if I've sweat a lot during that exercise, I often will drink a 3rd LMNT packet dissolved in about 32 ounces of water after I exercise. LMNT comes in a variety of different flavors, all of which I find really tasty. I like the citrus, I like the watermelon, I like the raspberry. Frankly, I can't pick just one. It also comes in chocolate and chocolate mint, which I find taste best if they are put into water, dissolved, and then heated up. I tend to do that in the winter months because, of course, you don't just need hydration on hot days and in the summer and spring months, but also in the winter when the temperatures are cold and the environment tends to be dry. If you'd like to try LMNT, you can go to drinklmnt, spelled lmnt.com/Huberman, to try a free sample pack. Again, that's drinklmnt.com/Huberman. Okay, so let's talk about protocols to improve working memory, specifically by way of changing levels of dopamine in the brain. Now, I've discussed dopamine many times before on this podcast. In fact, we have entire episodes devoted to optimizing and regulating dopamine. And of course, dopamine comes up within the context of the ADHD episodes and other episodes as well. And again, if you have specific questions about dopamine or any other topic for that matter, if you go to hubermanlab.com, that website has been engineered so that you can put one word, such as dopamine, but also multiple keywords, so perhaps dopamine exercise or dopamine cold plunge, etc., into the search function, and it will take you to the specific timestamps of multiple episodes where those topics were discussed, as well as newsletters where some of that information has been condensed into short PDF form, etc. So we certainly are going to cover some material about improving dopamine for sake of improving working memory now. But if you're generally interested in the science and pharmacology of dopamine and protocols to modulate dopamine levels, all of that can be found at hubermanlab.com. Okay, so let's say you have a short working memory span or a moderate working memory span, and you want to experiment with increasing levels of dopamine for sake of improving working memory. Now, there are a lot of different ways that one could imagine doing that. Let's start with the behavioral tools known to increase dopamine stores. That is, shown in peer-reviewed studies to increase dopamine stores within certain circuits of the brain that are relevant for working memory performance. And the protocol that immediately leaps to mind is the use of certain non-sleep deep rest protocols. Now, non-sleep deep rest, or NSDR, is actually a term that I coined because there is a practice that's been established for many hundreds of years called yoga nidra, which actually means yoga sleep, whereby individuals, potentially you, if you decide to do them, lie down, listen to a script, that is, listen to an audio script, which generally instructs you to do long exhale breathing, to deliberately relax your musculature of your face and of your body. And yoga nidra typically also involves doing certain intentions. And the instruction always given at the beginning of yoga nidra is that you should try to not fall asleep. Now, some people sometimes fall asleep, some people don't fall asleep, but the idea, and there are data to support, that yoga nidra puts people into kind of a shallow pattern of sleep, certainly not deep sleep and not rapid eye movement sleep, but it's a very interesting and unusual brain state for which we're starting to understand more. And actually, I have some plans in the not too distant future to collaborate with Matthew Walker, the author of the book Why We Sleep, and some other colleagues to try and figure out what exact patterns of neural activity are taking place in the brain and restive nervous system during yoga nidra, and this similar protocol, which I call non-sleep deep rest. The difference between yoga nidra and non-sleep deep rest is that non-sleep deep rest doesn't include any of the intentions and removes a lot of the kind of opaque or sometimes called mystical language from the protocol. Now, a great thing is that yoga nidra scripts or protocols, as well as NSDR scripts or protocols, are available totally zero cost. You can find them certainly on apps like Waking Up, but also on YouTube. For instance, if you put NSDR and my last name, there's a 10-minute NSDR script there. There are a lot of Yoga Nidra scripts. If you prefer a female voice, there are a lot of different excellent female voices out there. One in particular that I like very much is Kelly Boys. First name Kelly, last name Boys. She has both Yoga Nidra and NSDR scripts of various durations of anywhere from 8 minutes all the way out to, I believe, 45 minutes. Why am I telling you all this? Well, there have been several studies, but in particular one, and I do realize we're talking about only one study, but the results are really intriguing as it relates to what we're talking about today. In this study, they had individuals do effectively an NSDR protocol. They call it Yoga Nidra, and the protocol they used was essentially a Yoga Nidra script. They had people lie down and listen to a Yoga Nidra script and to perform Yoga Nidra, and they evaluated the amount of dopamine available within the brain both prior to and after performing this Yoga Nidra script. And what they discovered was that after performing a Yoga Nidra protocol, the baseline levels of dopamine, that is the amount of dopamine available in the basal ganglia and a few other structures of the human brain, of course these are humans, was increased by as much as 60% as compared to individuals that did a different protocol, not Yoga Nidra, not NSDR. Now, did that study evaluate lots of different durations of Yoga Nidra, aka NSDR? No. They looked at fairly long hour-plus Yoga Nidra sessions. However, there's some other data that have explored Yoga Nidra, aka NSDR, in the context of cognitive performance and a few other circumstances, all of which point to the fact that cognitive performance, and in particular cognitive performance tasks that have a working memory element to them. So they weren't the exact working memory tasks that you did earlier, but they have a working memory element to them. That is, subjects had to keep certain small batches of information in mind and then discard that information in order to be able to perform the task well. All of those show significant improvements in task performance. So while something like NSDR or Yoga Nidra might sound kind of mystical or kind of, wishy-washy, or I guess as the kids say, weak sauce to some of you, it is anything but weak sauce. It is really powerful stuff. And it's powerful stuff as it relates to the very neurochemicals and neural circuits that are involved in working memory. So if I were to take a step back and just say, okay, what are some zero cost, very low, if any risk protocols that one could perform in order to improve dopamine levels without having to ingest anything, take anything, really do much of anything at all, except lie there, do this progressive muscle relaxation. There are a few other things involved in NSDR as well, which you'll learn if you decide to try them, and improve or increase the levels of dopamine availability in the brain significantly. Well, then NSDR and Yoga Nidra really are the first line tools if one wants to do that. I think it's reasonable to say that. And as I mentioned before, there's no reason to think that there's any risk of doing NSDR, Yoga Nidra, provided that you're lying down in a safe place as opposed to like in the middle of the road or something. But assuming you do it in a safe location, I would encourage you to try it for 20 to 30 minutes when you first explore it. Perhaps you do longer, although I personally have a hard time doing long Yoga Nidra scripts regularly. A full hour is a big commitment. I don't generally have that much time. I often will do a 10-minute NSDR. Have there been brain imaging experiments done for each and all of these Yoga Nidra scripts to determine the amount or if there's any dopamine increase within the brain? No. But I think that we can safely extrapolate from that wonderful study out of Scandinavia that showed that when human subjects do this Yoga Nidra protocol, that there's a significant increase in baseline dopamine levels within key neural structures that relate to working memory. Now, many of you have perhaps heard that getting in a cold plunge or taking a cold shower, or provided you can do it safely, getting into a cold ocean or a cold lake can significantly, maybe even double or even triple your circulating dopamine levels. And indeed, that is true. It has been shown that when people get into cold water, typically up to their neck, and that cold water, by the way, can range in temperature anywhere from low 40s to low 60s, depending on how long you stay in, that there is a significant increase in the so-called circulating catecholamines. What are the catecholamines? The catecholamines are dopamine, norepinephrine, and epinephrine. Now, the evidence for the catecholamine increase in response to cold water mainly stems from two studies, and in particular one. And in that particular study, they had people get into, I wouldn't say super cold water. It was in the low 60 degrees. And by the way, I'm speaking in Fahrenheit here. And they had those human subjects submerged in water up to their neck. I think they actually had them sitting in lawn chairs on the bottom of a pool. But again, their heads were above water so they could breathe. And they stayed in for quite a long while, 45 minutes or longer. And it was observed that there was a big, statistically significant increase in epinephrine, norepinephrine, and dopamine that lasted several hours or more. This is one of the reasons why, if you've ever done deliberate cold exposure, as it's called, it often is uncomfortable when you get in, but then when you get out, you feel different. You feel really good in most cases, provided, if you're me, you take a warm shower afterwards. Yes, I like to do that. I realize if you want to increase your metabolism, perhaps it's better to not warm up afterwards. I like a nice warm shower or to get in the sauna afterwards. That's just me. But nonetheless, deliberate cold exposure clearly induces a state shift of mind and body that most people, provided they do it correctly and they don't go into water that's far too cold for them for too long, they report as pleasant. And I think it's reasonable to assume that some of that is the consequence of these increases in catecholamines, which is why many people opt for a cold shower, which if you're me, cold shower followed by a warm or hot shower or a cold plunge in the morning, or maybe even just once or twice a week. Many people like them. Typically, people like getting out of them and the feeling that they have after they do them, although some of you sickos really like the feeling of getting in and being in it, but not me. The point here is that if we were to take a look at the landscape of zero-cost behavioral tools, in fact, behavioral tools that could potentially save you money, meaning reduce your heating bill, that are known to increase the very neurochemicals, aka dopamine, that are involved in improving working memory, I think it's reasonable to assume that a cold shower about 30 to 60 minutes prior to doing any kind of working memory task or any kind of activity that would require increased focus could be, okay, we don't know, the specific studies have not been done, but could be, in theory, it makes sense mechanistically, it's logically sound, could be done after deliberate cold exposure. And indeed, many people report not just feeling a bit of, mild euphoria or feeling good after deliberate cold exposure, but also an increased capacity to focus. In fact, so much so that a lot of people who do deliberate cold exposure say that they don't require as much caffeine in order to maintain their alertness and energy, which shouldn't be surprising to us at all, right? I mean, it's increasing catecholamines. We know this. So that's another protocol that you could explore as well. Is there an important difference or not between deliberate cold exposure done by cold shower or deliberate cold exposure in a cold plunge or the ocean? Frankly, there haven't been a lot of studies comparing those, but I think it stands to reason that if you have access to a cold plunge or a cold body of water that you can safely get into up to your neck for 30 seconds to a minute, if it's 50 degrees or less, right? If you get in colder water, we know, for instance, if you get into, say, 45 degree water and you only get in for 30 seconds, you're going to get a big increase in the catecholamines, perhaps as big as the catecholamine increase that you would get from being in 60 degree water for 45 minutes. Most people don't have 45 minutes to sit around in water up to their neck. So most people opt for 30 seconds to as much as 3 minutes deliberate cold exposure in a shower or cold plunge or other body of water. Again, only do this if you can do it safely. Never, ever, please, for the love of God, please never, ever do any kind of hyperventilation breathing or breath holding while doing deliberate cold exposure, because you can pass out, you can die. Don't combine breath work and deliberate cold exposure. Just don't. Separate those two things completely, okay? But deliberate cold exposure, we know, is a very reliable way to increase the catecholamines, which includes dopamine. So if you want to explore deliberate cold exposure protocols, get into the nuance of temperature and duration, etc., you can find that completely zero cost. Go to hubermanlab.com, go to the menu tab, scroll down to newsletter, and go to the cold exposure newsletter where it details all of that in short PDF form. Now, some of you are probably asking, hey, what if I was in the high or long working memory span group? I ought to have high baseline levels of dopamine. Should I not do yoga nidra or NSDR? Should I not do deliberate cold exposure? Well, there you're just going to have to experiment. Again, there's essentially zero risk to doing yoga nidra NSDR, as I mentioned before. Deliberate cold exposure, there's always some risk getting into water, cold water. People always want to know how cold. Well, the newsletter gets to this, but I'll just tell you right now as well. The ideal temperature is the temperature that you can safely get into and stay in for a duration of 30 seconds to 3 minutes before getting out. Some people opt to go longer, but I think 30 seconds to 3 minutes is a good duration to work with for most people, especially if you're going to do it frequently. So the temperature should be safe for you to stay in for that duration, but uncomfortable enough that there's some impulse to want to get out, that you have to kind of work to stay in there, that you have to kind of overcome that adrenaline release and the impulse to get out. Okay, so For some people, that's going to be 45 degrees. For some people, it'll be 40 degrees. Depends on how cold adapted you are. Depends on how rested you are. There is no specific temperature. You have to really gauge for yourself. And so err on the side of caution, and you can experiment provided you experiment within the margins of safety. So if you found during the working memory task that you took today that you have a very good working memory, I don't think there's any reason to avoid Yoga Nidra, NSDR, and deliberate cold exposure. In fact, there may be reasons to increase your dopamine and other catecholamines by way of NSDR, Yoga Nidra, deliberate cold exposure. Perhaps for working memory performance, maybe it could increase further. Perhaps it would decrease performance, in which case there, you got your answer. You don't have to do those protocols again, and you certainly wouldn't want to do them before anything that involves a lot of working memory and attention. But of course, those protocols have other benefits as well. So there's no reason to avoid them entirely, just perhaps avoid them within the context of trying to improve working memory. However, if you're somebody that has challenges with working memory, challenges with attention, challenges with focus, well, then I think that the protocols I've been talking about up until now would be an excellent first foray into the sorts of things that you could do to increase dopamine and, of course, those other catecholamines as a way to see whether or not it augments your focus and attention and working memory capacity. Now, some of you are probably shouting. What about exercise? Doesn't exercise increase dopamine? It does. Yes, there are other things that increase dopamine. It's not just exercise. There are activities that increase dopamine. Some people are probably saying, wait, doesn't playing video games increase dopamine? Sex increases dopamine. Chocolate increases dopamine. Yes, indeed, those things can increase dopamine. What's interesting and important about the protocols I've been talking about, however, NSDR, Yoga Nidra, deliberate cold exposure, is not just that they increase dopamine, but the duration over which they increase dopamine. Okay, this is very important. If you want to understand more about the relationship between dopamine spikes, as they're called, and dopamine baseline, and why I'm emphasizing these tools that cause large, long-lasting increases in baseline dopamine, check out the episodes I did on optimizing dopamine. We've got a link to them in the show note captions. Now, before I talk about other ways to increase dopamine for sake of improving working memory, things like over-the-counter supplements like L-Tyrosine, Mucuna Pruriens, things like that, I do briefly want to mention, and I promise briefly, I know sometimes I say briefly and then I spend 20 minutes telling you about something, but very briefly, I just want to spend 2 minutes telling you about protocols that we do not yet know whether or not they increase dopamine levels, but we do know that they improve working memory, because after all, this episode is about working memory, not just about dopamine in working memory. It has been shown that the use of binaural beats, binaural beats being the presentation or the listening to sounds of different frequencies in the two ears, typically by headphones. I think that's been shown to work best. And there's a subtraction between the two frequencies such that the brain tends to entrain or start to follow a particular frequency within not the entire brain, but certain neural circuits. So if you've heard of, say, 15 hertz binaural beats or 40 hertz binaural beats, that doesn't mean that you listen to a 15 hertz sound or a 40 hertz sound. You listen to two different frequencies of sound. Right? Hertz is just a measurement of sound frequency in each of the two ears, and then the difference between them is 40 hertz or 15 hertz. And there are several studies that show not enormous, I want to be clear, small to moderate improvements in working memory performance, but in some cases, significant improvement. And I'll provide a link to these two papers in the show note captions, but I'll just briefly describe them by way of their title and their major conclusions. The first is a study entitled The Effects of Binaural and Monaural Beat Stimulation on Cognitive Functioning in Subjects with Different Levels of Emotionality, a really interesting study published in 2019. It was a relatively small number of subjects, only 24 participants, 16 males, 8 males, between 19 and 31 years old. Listen to these 40 hertz binaural beats. And by the way, it's very easy to find apps and other sources of 40 hertz binaural beats at zero cost or nominal cost out there. You simply look for 40 hertz binaural beats and looked at performance on working memory tasks, as well as some other cognitive tasks, and found in some cases a small to moderate but significant improvement in cognitive performance on working memory tasks. The aspect of the study looking at emotionality did not find a significant effect, so it doesn't seem that emotionality impacts things there. But nonetheless, that study plus the other one entitled The Effect of Binaural Beats on Visuospatial Working Memory and Cortical Connectivity, this was a study published in 2016, found generally something similar. In this case, they were using 15 hertz binaural beats, and here I'm paraphrasing, produced network activity characteristic of high information transfer with consistent connection strengths. What they're really talking about is changes in neural activity patterns within the brain that led to, or at least were correlated with, improvements on visuospatial working memory. Visuospatial working memory tasks are different than the working memory tasks that you performed earlier. Visuospatial working memory tasks involve the cognitive generation that is within your head of the so-called visuospatial sketch pad. So it's this idea that you see something and then you kind of sketch it out in your mind. You have to know the relationships between things in space, pay attention to what they are, keep those in mind, again, because it's working memory just as long as it's necessary to perform a task. That's what visuospatial working memory is. As you can imagine, it translates to an enormous number of everyday activities required for focus and attention and learning and performance. And indeed, 15 hertz binaural beats was able to produce a small but significant improvement in that sort of working memory task. So I want to emphasize again, we don't know the relationship between binaural beats and dopamine, at least not from these studies, but I felt I'd be remiss if I didn't mention these two studies that show that 40 hertz binaural beats, 15 hertz binaural beats can indeed improve working memory performance. And in these sorts of scenarios, individuals are listening to the binaural beats while they are doing the working memory task, and in some cases before they are doing the working memory task. Either seems to work. It depends on the study. There are a bunch of other studies, but I thought I'd mention binaural beats because I know a number of people are interested in them. Again, non-pharmacologic, zero cost because you can find tools for binaural beat generation, zero cost out there, approaches to improving working memory. Okay, what about over-the-counter compounds that are known to increase circulating dopamine that can potentially improve working memory, and that indeed have been shown in peer-reviewed studies to improve working memory by way of increasing circulating, presumably brain levels of dopamine? Well, I can think of two specific categories of supplements, that is, over-the-counter compounds that, at least at this point in time, are legal in the United States, that can increase dopamine levels. Those two are L-Tyrosine, which is an amino acid precursor to dopamine, and Mucuna pruriens, which is believe it or not, it's a velvety bean, or the outer component of this velvety bean that contains or is equivalent to 99% L-Dopa. L-Dopa is a key component in the biochemical cascade leading to the production of dopamine. In fact, L-Dopa is often prescribed for Parkinson's patients as a means to increase their dopamine levels. There are at least 3 studies that I am aware of the use of Mucuna pruriens to increase dopamine for the treatment of Parkinson's. In other words, Mucuna pruriens increases dopamine levels. And yes, it has been shown to improve some of those symptoms of Parkinson's patients. We're not talking about treatment of Parkinson's today. I want to caution people against any sort of use of supplements to treat Parkinson's or other conditions without consulting your doctor. All right, that's very, very critical to point out. If we're talking about ways to increase dopamine for sake of improving working memory by way of supplementation, I think we should start with L-Tyrosine, because L-Tyrosine, unlike Mucuna pruriens, is a bit further up. Actually, it's way further up the biochemical cascade leading to dopamine production. However, it has been shown in several studies that L-Tyrosine supplementation can indeed increase dopamine. And moreover, and here I'm quoting the title of a study published in 1999, which I realize is a few years back, but of course there's some excellent studies from a few years back or more. Tyrosine improves working memory in a multitasking environment. Now, this particular study from Thomas et al. Has some interesting aspects and some aspects that made me go a little bit wide-eyed, but not necessarily wide-eyed because the results are so dramatic. In fact, when one looks at all of the data in this paper, what you find is that supplementing with L-Tyrosine, as they did in this study, did indeed lead to improvements in working memory under multitask conditions, as the title suggests. Those improvements were significant, but they weren't enormous. Okay, they were statistically significant, but they were not enormous increases. Now, what was enormous, and the reason I got wide-eyed and still get wide-eyed, is that the dosages of L-Tyrosine used in this study are really big. They had subjects take 150 milligrams per kilogram of L-crystalline tyrosine. I had them take it in applesauce for whatever reason, or placebo. And they did a number of different control conditions to make sure that whatever effects of L-Tyrosine they observed were in fact due to L-Tyrosine supplementation. Why am I going wide-eyed when I see this 150 milligrams per kilogram of tyrosine? Well, I weigh 220 pounds, so that's about 100 kilograms. So if I weigh 100 kilograms and it's 150 milligrams for every kilogram, That means that if I were a subject in the study, that they would give me 15,000 milligrams, that is 15 grams of L-tyrosine prior to doing these cognitive tasks. Now, 15 grams of tyrosine to me seems like a very, very high dose. And I frankly can't in good conscience recommend that. Why? Well, maybe I'm just hypersensitive to L-tyrosine, but I've taken 1,000 or 1,500 milligrams of L-tyrosine, and I've definitely experienced an increase in alertness from taking 1.5 grams, not 15, 1.5 grams of L-tyrosine. And in fact, at a subjective level, I can feel a meaningful increase in alertness and focus from 500 milligrams of L-tyrosine. So I can't in good conscience suggest that people replicate the exact dose protocols within the study. Nonetheless, the study, as the title suggests, shows that supplementing with L-tyrosine can indeed increase working memory capacity, especially in a multitasking environment, which in many ways carries over to the sorts of requirements for working memory and attention capacity to get through life in a very focused, for lack of a better word, way, in a very regimented, do this, do that, task switch, multiple things, interleave. That's what moving through one's day, or at least work day, or anything that requires cognition and focus entails. So first of all, I'll just say what I always say when discussing any kind of compound or prescription drug: never add or remove any supplement from your supplement regimen, if you have one, without consulting with your health provider first to make sure that you are safe to take that particular supplement. Now, many physicians, MDs, are not familiar with most supplements, so you'll probably need to bring some literature to the phone call or to the visit. But of course, there are many healthcare providers, including some MDs, that are open to supplementation, especially these days, as supplements have become, I would say, generally more accepted. I mean, there are certain ones like vitamin D3 and fish oils and things like that that are more common than L-tyrosine, but there are many physicians who are open to discussions about supplements such as L-tyrosine. If you know that you can supplement with L-tyrosine safely and you opt to do so, what dosages would you potentially take? Well, here we have to look at the dosages used in these studies. I think it's only fair, it's only safe that we acknowledge that these dosages are really, really high. And I think the safe thing to do would be to start with the minimal effective dose. So if you weigh 50 kilograms, rather than start right off with, the equivalent dosage to this study, maybe you start with 250 milligrams of L-tyrosine. If you weigh a bit more like me, or 100 kilograms or 75 kilograms, maybe you take 500 milligrams of L-tyrosine and see whether or not you experience a significant effect on working memory, attention, and performance. So the idea here is to establish the minimal effective dose. I should also point out that some people, not all, but some people experience a bit of a crash after L-tyrosine supplementation, such that they feel more alert, more focused, better ability to perform working memory tasks, move about their day, but then 3 or 4 hours later experience kind of a drop. So you need to be mindful of that. In fact, you need to be mindful of any kind of pharmacology where you're increasing dopamine. This is one of the reasons why I like the behavioral protocols that we talked about earlier, because they're known to create big but long-lasting and slowly tapering off increases in dopamine and other catecholamines. Now, for those who are curious about and perhaps even want to try Mucuna Pruriens, please absolutely talk to your doctor first. Mucuna Pruriens is essentially the equivalent of L-Dopa. L-Dopa is a prescription drug, as I mentioned before, and Mucuna Pruriens potently increases dopamine. What dosages of Mucuna Pruriens can increase dopamine? Well, typically in studies of Parkinson's patients, but also studies exploring typical people who don't have Parkinson's in cognitive tasks or in sports performance have explored anywhere from 1 to 5 grams of Mucuna Pruriens. Mucuna Pruriens, again, is a very potent way to increase dopamine. And here, if your healthcare provider approves it and you decide to try it, I would suggest starting with a very, very low dose, again, to find the minimal effective dose. So maybe even just 500 milligrams, not even going to the 1 gram dose, maybe even 250 milligrams, and really evaluating how much Mucuna Pruriens can produce a meaningful impact on working memory and attention for you. So Mucuna Pruriens is kind of a bridge between over-the-counter supplements and prescription drugs. I say it's a bridge because it is oh so similar to that prescription drug L-Dopa. And of course, there is a long list of prescription drugs that are known to be dopamine agonists, many of which, in fact, have been shown to improve working memory. You already learned about one of those before, which is bromocriptine. Now, you need a prescription from a physician to get bromocriptine. But bromocriptine, we know, based on that work from Desposito and colleagues that I talked about earlier, increases dopamine. It does so in about 90 minutes. It achieves peak levels of dopamine in about 90 minutes and improves working memory in individuals that start off with a low working memory span. And we know from neuroimaging those are the individuals with lower baseline levels of dopamine. So should you run out and ask your doctor for bromocriptine? Maybe. Most doctors won't prescribe bromocriptine for that reason. I should mention that work from Desposito Lab and other laboratories has shown that one of the hallmark features of traumatic brain injury, especially frontal lobe injury, as well as certain neurodegenerative conditions like Parkinson's, but other forms of dementia, as well as ADHD, involve deficits in working memory and attention, which makes sense given what we know about the symptoms of those conditions. And that bromocriptine has been prescribed off-label for the treatment of those conditions to some degree of success. However, those are off-label circumstances. Right now, as far as I know, bromocriptine is not prescribed specifically for those conditions at a kind of whole population level. It's not one of the drugs on the lookup table for ADHD or TBI, but certain well-informed neurologists and physicians do prescribe it for that reason. There are other dopamine agonists that are relevant in this context. The ones that I think most of you will be familiar with are the drugs that increase dopamine and norepinephrine for the treatment of ADHD. And I did an entire episode of the Huberman Lab podcast about those compounds, things like Adderall, things like Ritalin, which by the way is quite different than Adderall in terms of how much dopamine relative to norepinephrine it causes the increase of. I cover all that in those episodes. Again, you can simply go to hubermanlab.com, put ADHD, Adderall, or ADHD, Ritalin, and I talk about other things as well. I also talk a little bit about modafinil, which is a entirely different category of drug known to improve cognitive performance, in some cases in ADHD, but in everybody. So there are a lot of different drugs that can improve working memory. Most of those do so by increasing transmission of dopamine or availability of dopamine, somehow changing dopamine levels in the brain by increasing them. So if you're somebody that has challenges with working memory, focus, and attention, please see those episodes and please talk to your doctor about potentially using pharmacology to increase dopamine. However, and this is very important, many people who have challenges with focus, attention, and working memory and fall under the category of subclinical levels of ADHD, and even some individuals with ADHD, young and old, manage their symptoms and in some cases improve their focus through the use of behavioral tools, nutritional tools, supplement-based tools in ways that either allow them to reduce their total prescription drug dosages and in some cases come off them entirely. Now, I am definitely not saying that people should come off those drugs entirely. And in fact, I want to take a really firm stand here because I know this is a bit controversial, but I'm just going to tell you, having evaluated the whole literature several times over now, I personally believe that there is a strong case for certain children and adults to take these compounds that increase dopamine and epinephrine. Yes, those compounds are different forms of amphetamine, but those compounds we know can increase neuroplasticity, the rewiring, LTP, LTD, etc., within the neural circuits that control focus, attention, and working memory. And so they do have their place for certain individuals. We don't want to rule those out. Are they overprescribed? My feeling is that yes, they are probably overprescribed. However, there are a number of individuals that strongly benefit from them as well. So if you are going to explore the use of those compounds for sake of improving working memory, certainly if you're going to explore them for sake of improving working memory and focus in young kids, please, please, please talk to your physician. Because they're prescription drugs, you would need to talk to a physician anyway. But regardless of whether or not you're trying to improve focus and working memory in a child, in an adult, someone with TBI, someone with Parkinson's, I think it stands to reason that you would arrive to that conversation with some knowledge of not just the prescription drugs that are potentially available, but also some of the supplement-based tools, some of the behavioral tools, because as we know, and as a good friend of mine who's an excellent physician says, better living through chemistry still requires better living. Meaning, yes, prescription drugs can have a positive impact on these aspects of brain function in a way that can really improve lives, but that behavioral tools also work. In fact, they can collaborate in a very synergistic way to increase the amount of neuroplasticity in the relevant circuits. So I'm of the mind, and I think more and more people out there, I like to think, are of the mind that behaviors, nutrition, supplement-based tools, and prescription drugs all can have their place to varying degrees depending on the circumstances and the individual. Okay, so today we talked about working memory, this incredible capacity of our brain. In fact, a specific set of brain circuits designed for us to absorb information, that is, perceive it in our environment, use the relevant parts, and then chuck it, just get rid of it, forget it. So very different than short and long-term memory, which we also discussed, and we talked about a few of the mechanisms as well. I think you'll agree that working memory is one of the more incredible aspects to brain function. I mean, if you think about it, this is a set of neural circuits that engage the same algorithm over and over in different contexts in order for us to be able to navigate new environments, familiar environments, to interleave different activities, different strategies, to task switch, to rule out distractors. It's oh so critical to every aspect of our waking life. And fortunately, there are also zero cost and low cost behavioral, supplement-based, and prescription drug approaches to improving this incredible thing we call working memory. So it was a pleasure to share some of those with you today as well. If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, please subscribe to the podcast on both Spotify and Apple. Please also check out the sponsors mentioned at the beginning and throughout today's episode. That's the best way to support this podcast. If you have questions for me or comments about the podcast, or guests or topics that you'd like me to host on the Huberman Lab podcast, please put those in the comments section on YouTube. I do read all the comments. During today's episode, and on many previous episodes of the Huberman Lab podcast, we discuss supplements. While supplements aren't necessary for everybody, many people derive tremendous benefit from them for things like improving sleep, for hormone support, and for focus. To learn more about the supplements discussed on the Huberman Lab podcast, you can go to Live Momentous, spelled O-U-S, so that's livemomentous.com/Huberman. If you're not already following me on social media, I am Huberman Lab on all social media platforms, so that's Instagram, Twitter, now called X, Threads, Facebook, and LinkedIn. And on all of those platforms, I discuss science and science-related tools, some of which overlaps with the content on the Huberman Lab podcast, but much of which is distinct from the content on the Huberman Lab podcast. Again, that's Huberman Lab on all social media platforms. If you haven't already subscribed to our monthly Neural Network newsletter, the Neural Network newsletter is a completely zero-cost newsletter that provides podcast summaries and protocols in the form of brief PDFs of 1 to 3 pages in which I detail things like how to do deliberate cold exposure and some of the science behind it, how to regulate your dopamine levels, how to improve your sleep, and on, everything from focus, neuroplasticity, and all of which is available, again, completely zero cost by going to hubermanlab.com, go to the menu tab, scroll down to newsletter, and simply sign up by providing your email. And I want to emphasize that we do not share your email with anybody. Thank you once again for joining me for today's discussion about working memory and ways to improve your working memory. And last, but certainly not least, thank you for your interest in science.